Hi. In this video, we are going to prove using what we know about congruent triangles. And so during these kind of proofs, we want to make sure that we remember the different shortcuts, which are the postulates and theorems that we know to prove triangles congruent. And so we know angle, angle, side, side, angle, side, angle, side, angle, side, 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 and then hypotenuse leg. So we know these as our shortcuts for proving triangles congruent. And so we want to make sure that we have each of these objects, and so we're going to keep an inventory as we go in these proofs so that we know that we have every object that we need. So the first thing we do is once we are given a proof, we want to mark up our picture so that we can just have a visual. So given AD is congruent to CD in this triangle, we'll mark it with a little congruency tick mark. AC is perpendicular to segment BD. Now, we know perpendicular gives us right angles, so then we can mark these right angles. And then looking at the picture, we go ahead and look at the different things that we can assume from the picture. And there are only really three things that we can assume from a picture. We can assume that congruence is reflexive, so with shared side or a shared angle. We can assume a linear pair, which would be supplementary angles. And then we can also assume vertical angles, which by the vertical angle theorem tells us that the angles are congruent. So those are the three things that we can assume from a picture. In this case, we see a shared side, and we're going to mark that. And so looking at this, I have a side, an included angle, because we know by the right angle theorem that all right angles are congruent, and then a shared side. And so by side angle side congruency, I can prove the triangle's congruent. So we always start with our given. Now notice when we're filling in the flow proof, the logic is kind of already built in and given to us. So if I were to write AD is congruent to CD here, that already gives me congruent sides for my side angle side. So these boxes really wouldn't be necessary. So this box must not be for the congruent segment. But this given piece AC, segment AC is perpendicular to segment BD. Well, perpendicular we said gives us the right angles, so we actually are going to need more boxes. So that's how we're going to know what box to fill, what to fill in what box. So AC is perpendicular to segment BD. What do we know from perpendicular? Well, we know that perpendicular lines give us right angles. And so we can go ahead and say that angle ADB and angle CDB are right angles. Well then, what do we know about right angles? We know that right angles give us congruent angles by the right angle theorem, which says all right angles are congruent. So then I can go ahead and state that angle ADB is congruent to angle CDB. And that branch is complete. So let's go ahead and finish with another given. The other piece that's given is that segment AD is congruent to segment CD. And something I should have noted here, once we have that our angle is congruent, we're going to mark that as our inventory for, okay, there's the angle that we need. AD is congruent to CD. Well, there's the side that we need. And then we know by reflexive property of congruence that BD is congruent to BD. Again, there's the other side. And based on that picture, side angle side congruency tells us that triangle ABD is congruent to triangle CBD. And so using what we know about our basic definitions, we were able to kind of go through and fill in so that we got all of the necessary objects in the triangle to prove congruence.